So, hello and welcome to another session. Today the plans got a bit messed up because I was a bit sick. Now I'm okay. Also, I originally wanted to talk about monitoring, but during the last workshop, I think there were lots of questions left unanswered about the role of drone and Kaniko and the other tooling. So I thought that the logical continuation would be actually to finish talking about drone and Kaniko and then actually talk about how apps get deployed into the Kubernetes cluster. Yeah, the agenda is still the same. Get more people involved with the place. And these sessions are supported by Startup Estonia. But yeah, the goals of current workshop/talk is further dig into what is the scope of drone, what is the scope of Kaniko, what is the scope of Harbor, and what is the scope of Argo. I think and also what is Helm, because Helm we haven't really touched so far at all. I wanted to postpone it because it adds another complexity layer on top of everything to get things confused. But yeah, I drew this chart basically, which hopefully comes on the screen as well soon. So basically, like everybody keeps talking about GitOps nowadays, but what does GitOps mean? I think there's lots of different opinions about GitOps, and basically so one aspect is building the Docker images. That the Git repo would be the source for the Docker image, right? So that is definitely one key aspect here. But the other aspect is that the manifests that are used to deploy the applications, these should be also, okay, nice, we've got picture back on the screen as well. The other aspect is that the manifests that we write to deploy into the Kubernetes cluster, those should be also in some sort of Git repo. And I think this is maybe like your classic split between these two, that software developers would be working on their Git repos where they write the software, and sysadmins would be working on their Git repo which contains the Kubernetes manifests. That's probably the easiest split, and it maps nicely to the components that we use here as well. So we would use drone to build the Docker image from a Git repo. So drone would do the Git clone from that Git repo. It would run the Kaniko somewhere, and the outcome of Kaniko, the produced Docker image, would be then pushed to the Docker registry, which in our case is this Harbor. From that Docker registry, the images would become available for the Kubernetes cluster, which would then be able to basically do Docker pull from the Docker registry and run those images. But Harbor repo can contain different versions of images. Which version are we going to run? So all of that information should come somewhere, and that is the source of truth for that is the Git repo that contains these manifest files. So of course there are many ways to deploy the manifest to the cluster. You could do it manually, run just kubectl apply on your machine and apply the changes to the cluster, and then that's it. But if you want something more automated, then at least in more traditional setting, what I've heard what people are using in practice is that they would use GitLab to track the Git repo, and then the GitLab would have credentials to talk to the Kubernetes cluster directly, and then it would basically do kubectl apply based on the contents of the repo. But I would say that really is, let's put it, how to put it nicely. It's a simple way to do this, but For more complex scenarios, you really want to have Argo. And I think, have I even showed Argo in previous ones?
You showed it quickly.
Quickly, yes. I think I showed it briefly. So this is Argo CD. It's a software that runs inside the Kubernetes cluster. And basically every Argo application is tracking some sort of Git repository and applying the changes to the cluster. So for every user that is in this cluster, there is actually already a Argo application added automatically, and it actually tracks this lab template repo. Let's take a quick look. What is there? This is, I mean, this has nothing to do with any particular application. Is it? Did I remove it? Really? I think I maybe renamed it or something. Okay, I'll try to explain first and look where it is. And this lab template basically contains some manifests that, for example, set up the access controls for you guys. So you can access that namespace that was created, because otherwise it's a bit locked down and you cannot access it. I think I have it. Yeah, lab template is here. Let's look around here a little bit to see what is inside here. So it's a Git repo. There's some README file, and inside here we've got a bunch of templates. These are now actually Helm templates, because I cannot have static manifests for all of you. Each one of you has some sort of uniqueness that, there's some changes that are related to your username differences and so forth. So let's take a look at, for example, this Prometheus manifest here, or rather a template. So this is the code that is conditionally enabled, and I've exposed it here in the sandbox creation dialog. When you enable, set up dedicated Prometheus instance for this sandbox, then this values.prometheus becomes true, basically. So the Helm chart is sort of a template for the manifest, and the actual values get added by this sandbox dashboard. I'll later show you how you can instantiate these Argo applications yourself. This is just to explain what's going on inside the template. So yes, Helm, you could think of it as a template engine for Kubernetes manifests, although they try to advertise themselves as a package manager for Kubernetes, but in my opinion, that description doesn't really work well. In maybe simpler language, yes, template engine for Kubernetes manifests works better. And the other aspect is that you can use a bunch of variables that are coming from the sandbox environment, like the hostname suffix. So I think this becomes something like prom-Lauri Võsandi.codemowers.ee. Yep, I think that's the one. So basically, the sandbox environment sets these variables, and each one of you, when you enable the feature flag, each one of you will get Prometheus instance added by this code. Let's see what else is here. So of course, to make Prometheus functional, it needs a service account, it needs role bindings, it needs some permissions, it needs an ingress to expose it on the internet, and it has some pod monitor objects as well. I guess this might be a good chance again to jump into the operators topic as well, because I think I've mentioned the word operator on several occasions, but haven't really fully tried to explain this. So, of course, you could run Prometheus yourself by having, kind deployment, and then having setting up a deployment manifest which starts up Prometheus for you. But the problem is that it becomes really clunky. There's lots of code there that needs to be added. And this kind Prometheus is so-called custom resource custom resource definition that is coming from the Prometheus operator And Prometheus operator, let's look at it. It's sitting inside the Prometheus operator namespace. It runs a pod, and it's a pod that has quite a bit of privileges to talk to the Kubernetes API, and it picks up all of these Prometheus definitions in all of the namespaces. So mine is here, Lauri Võsandi /Prometheus, and for every this definition, which now is toggleable through this feature flag, it will start a Prometheus pod in that namespace. So when I look inside my Lauri namespace, I see my Prometheus is running here. So basically, what the Prometheus operator does, it simplifies starting these Prometheus instances, and it allows you to also nicely define which resources should now this Prometheus monitor, because if you look below here, it hasn't been really confined down, but basically you can filter here what are the things that this Prometheus should monitor. And actually a bit more correct here would be that it would be confined down to my namespace wherever it is running, but it depends again the use cases here. And it introduces also, the Prometheus operator introduces also 4 different additional custom resource definitions, out of which I think the most useful is this pod monitor. And pod monitor is a definition that allows you to tell that Prometheus that please monitor this port on a specific port. So this is just a dummy definition which says that Prometheus should monitor itself. But if you keep adding applications, it simplifies your application design in the way that to enable a monitoring, you just add these 5 lines in the namespace of the application, and whichever Prometheuses think that it is applicable for them to monitor these pod monitors, it will start monitoring those pods as well. And it actually solves one important issue. What you would have otherwise is the composability of the configuration. Otherwise, you would need to have this mammoth Prometheus configuration file, which basically says, monitor this pod, monitor that thing, monitor that, and monitor that. So it breaks down this massive configuration file into fragments that are collected from these definitions, and which are independently addable, deletable, and modifiable. So yeah, I think the very applicable meme to this talk is that this bad boy can fit so many abstraction layers in it, and then you slap the car. Or who's gonna monitor the monitors and stuff like that, So it adds these abstraction layers that at first get you very confused, but in a very large installation, it starts to make sense. Yes. Any questions so far? Any questions on YouTube? So I think this will be one of those sessions where I'll be just jumping back and forth between different topics that we have partially covered in the previous ones, but just try to tie up the loose ends in a way. Let's see, the other one, rule selector. That's probably the second thing that you want to find, what you will find useful in the Prometheus operator. If I jump back here, yeah, let's go back to this one. This maybe tries to elaborate this. so if you do this split that the devs are developing the software, there is no manifest there, and SREs and DevOps are maintaining this manifest repo, then you will have one interesting issue if you do not decompose these pod monitors and alerting rules. So, of course, many of the Prometheus alerting rules will be generic, that it will be something on the infra side. You know, machines are running out of memory, machines are constantly loaded, disk I/O is slow. Of course, that is cluster-wide and should be handled by the infra team. But the moment you actually start exporting useful metrics from the application and you start writing alerts which are specific to one component, you will end up in a situation where if it's set up like this, you will have the application alerts actually in the sysadmin's manifest repo. And then you probably might gonna do some sort of splitting there as well. And then you will have a separate Git repo for every microservice source code base. But I guess like the holy grail here is to actually unify that and have the alerting rules next to the application. So let me try to give an example. So let's see if I have it here actually. Yes, that's a nice place. So this is one example of a Prometheus rule. Actually, let me give you another example which is maybe easier to understand. Node exporter has lots of interesting alerting rules. So node exporter is just a piece that exposes host level metrics, how much memory is available, how much disk space is available, and so forth. And we've actually installed the node exporter on other machines as well that are not part of the Kubernetes cluster. So this one in particular is a ZFS alert, which has nothing to do with Kubernetes, but the node exporter is exporting this from a machine that is running outside Kubernetes cluster. And the Prometheus rule kind is allows you to split up this. It used to be basically before having this Prometheus rule kind, you would essentially have big YAML file, which is part of the Prometheus config, which contains all of these alerting rules. And whenever you needed to add something, remove something, then you would basically edit this big file, make a git commit, and then push it to the Kubernetes cluster, and Prometheus would reload this. But with Prometheus rule kind, the very first thing is that you can break it down into smaller fragments. So this is still a very large alerting rule definition. There's lots of, host is under high load, host is under high out of memory, etc. All of these alerting rules are here. And since this is a infra team topic, it kind of makes sense that it's in a one place. It's not spread out between different Git repos. It's in one of the infra team's Git repos, which contains like the underlying infra alerting rules. But the moment you start adding application level alerts and metrics, that's when you find yourself in a situation where you need to start moving these alerts away from this big repo. And for example, for this log aggregator, I think we started splitting them up. So these are actually now alerts for an application, not anymore like some sort of generic host level metrics. So this is a metric that is coming from a pod. In particular, this is the one that I use in the log shipping daemon. It basically spits out the amount of errors. If there are some errors, I would get some alert. And this is now, I guess, where the Helm comes into picture a little bit, because with Helm, it becomes quite easy to bring back these manifests into the software components repository. Because basically then you can have something like this. So you would have still the same workflow for the Docker images, that the software component would provide Docker file and instructions for building a Docker image. But by putting the Helm chart into the software component repo, and by having it templatable, it becomes easier to actually install the component using the manifests that are generated by the Helm template based on the same repo, which means now that you can bring your Prometheus alerting rules into that repo, like if you have application-specific or component-specific alerting rules. And you will have those alerting rules versioned. I think that's even more interesting aspect to have, because then when you roll back the component, then you can also roll back the alerting rules, which kind of makes sense. Now, if you're asking why do I still keep the Git clone here, now this central Git repo becomes what is known as application of applications. So this is one of the patterns that Argo CD provides. And I would say one of the problems with Argo is that you can come up with all sorts of different ways you can use it. But I guess these two options are like the sane options to have. You might want to improve on top of either of those two, but generally speaking, these are like the two options that make sense. And when I say application of applications, that means essentially, let me show you what I mean by that. So Argo itself, you could think of it as an operator in a way as well, to make things more complicated. Argo has a built-in custom resource definition called application. And basically, if you apply this manifest, it will add a new application into Argo. And Argo will start deploying that application into some other namespace. And basically, a repository, like the application of applications repository, would essentially be a Git repo that just contains these things. So it's like the root for the other stuff that gets deployed in the cluster using Argo. And basically, let's say if you would have a blank cluster with Argo installed, you could use this application of applications repository to seed the whole setup. That you basically pull in this repo. It will tell Argo about all of the other repositories it should track, and it will like deploy the whole thing with Argo. So essentially, you could like seed install the whole thing with Argo like that. And the remaining question there is how would you handle image tags? That is probably the toughest question, because if you have a new release for the Git repo, then this should end up with a new image tag being deployed in the cluster, right? So again, for this, there's a couple different ways to do this. And Helm template here is the supporting factor as well. Very often what you would put in the Helm template is exactly the image tag that the application manifests would have variables for the image tags. And those would be filled in by Argo. Let me see if I can find some example. No, I don't have here actually. Yeah, actually the problem is that lots of the Helm related stuff I haven't done it on the case-based repo. But let's take a look. Okay, there's actually a good example here. Hello Helm. So that's the repo that you can try out if you want to deploy something with Helm or just play around with Helm a little bit. It doesn't, like from the software point of view, it doesn't contain anything interesting. It's just some Python script here. But let's take a look at the manifest that we have here. So this is like I don't know however you want to call this, a hybrid repo that it contains the application app.py. It contains the Docker file. So these are the inputs that are needed to build the Docker image. But at the same time, it contains the Helm chart. And Helm chart is just whatever, just meta info. It doesn't do anything meaningful. I think the requirement for Helm is that the file with this name exists. Otherwise, it refuses to work. And along or next to chart.yaml, you're supposed to have a templates folder, which now contains all of these Helm template files. And this is, I think this, yeah, it's basically Hello Flask. It was forked from the Hello Flask repository, so it's just like a Python web application, nothing interesting here. But what are the differences is that the image tag is substituted with is templatable, meaning that you can use a different repository here, you can use a different tag, or combine them. Oops. And one thing that's maybe worth mentioning. So once you like dig into Helm details, you will find lots of examples like Helm install, whatever, blah blah blah. Do not use this. I think every second example about Helm is that, you know, oh, awesome application, you can install it with Helm install. But the problem with the Helm install is that you don't know where it puts this stuff or what it even puts there. So in a very paranoid fashion, the very first thing that I do is that I run Helm template. Okay, Helm template needs to specify where is the chart. So if you have like cloned the repository that contains a Helm chart, you would use dot here because it's looking for the chart YAML file in the same folder. I think I'm not sure what's a good example for. Let's see here. Can I find a good example? Maybe Argo itself. Yeah. So a very usual workflow is this, that you will have some sort of instructions how to add a Helm repository. So Helm again introduces its own repository system, which is now distinct from Git repositories and Docker registry. If you would do it like in an enterprise way, I guess, then you would have a Helm artifactory which contains these builds of Helm charts. But I've never gone that far. I just stick to Git repos because otherwise I think it introduces so much complexity to the ecosystem that you will just go nuts. And in addition to that, you would need to find a place where you can store these Helm charts. Harbor, by the way, supports that. So if you would want to use it and you already use Harbor, then you can actually push them into the Harbor. But this is just the way these Helm charts are distributed and the way you can install them. And basically this thing just, it's in a way equivalent to adding like a apt sources repository, and then you can do apt-get update, and apt-get install would be something like Helm install. But Let me try to show you just quickly. If you're using a Helm chart that is coming from outside, then you can always do Helm template and whatever this org name / repo name is, this will now render the manifests that are used to install Argo. Let's just put it in a file, Argo YAML. So also I think that would be like a good idea to check, like what is it actually going to install into your cluster? Is it going to add service accounts? Maybe it's doing something, you know, unexpected. I've found I've become so paranoid about these Helm charts that I usually do this, and I actually go through what it would add into my cluster, because sometimes they do just lots of weird stuff, and sometimes the people who have written the Helm charts, they assume lots of things about your setup which might not make sense. So, okay, for example, in this case, you know, in order to have Argo talking to a Git repository, they have already included, you know, GitHub, GitLab, Bitbucket, org, so you wouldn't have to manually add the SSH public key of the server that your Argo will be talking to. And here we see another example, actually, how are these custom resources added? Like the kind application, kind Prometheus. All of these are kind custom resource definitions, and that is actually the definition for a definition. So you can write those yourself. You can introduce your own custom resources. If you're asking, like, where does it make sense to actually add custom resources, it's very... I think there's no good, I mean, like, I can't give you like a good answer about this, but I guess generally speaking is like when your application is somehow tightly integrated with the Kubernetes APIs, then it makes sense. So obviously Prometheus operator, like tooling to add Prometheus instances needs to be tightly integrated with Kubernetes API, so it makes sense that they have some sort of CRDs. Let's see where I have used custom resources. So all of this infrastructure plumbing I did for the sandboxes very heavily relies on custom resources. There's like for every user I create a custom resource with your email address and username. There's custom resources for Harbor, so I have some tooling that creates this Harbor project automatically. So source of truth for all of these is these custom resources. But yeah, point being here is that this tells you that Argo will add some custom resources into your cluster. So when you're gonna maybe later clean up and remove Argo, then you know that, okay, there's some custom resources that need to be cleaned up. But yes, this is Helm in a very condensed explanation. Basically like template engine that slightly resembles this Jinja or whatever Django used. And so you can have basically if-else statements and conditionals, and make your template, make your Kubernetes manifests templatable and customizable in a way. But I guess the main point here is that your Helm chart should describe how your application components relate to each other. Like let's say if you have an application that is composed of multiple pieces, then this template should describe how they relate to each other, and the values that get injected simply customize it for a particular instantiation or a particular instance of that application. Because in a cluster you might have your application might be installed, in multiple setups. Like one classic split is dev environment, staging, and production. So you would install the same application with 3 different settings, probably maybe with going to 3 different databases or something like that. The other case is that where your application actually needs maybe hundreds of similar setups of the same pods. Maybe it's doing some sort of machine learning thing or something like that. I don't know. And let's see. So Helm template renders this particular application. Since there is no value set anywhere, one way to set it is here. Set image equals foobar. and now it appears here. So that's one way, and that's actually what Argo will be doing with these. Picture flickered for a while. That is actually what Argo would be doing with these templates. It will git clone the templates from the microservices repo, and then it would use the values from the central repo, for example. The other aspect here is that there is also values.yaml, which I haven't defined. Let's put here image foobar baz. So yes, it's working. And that's the one that contains the defaults. And Argo can override these. So what I would usually do here is that if I have, I don't know, Lauri Võsandi, my app, then here I would put just :latest, which would make sure that the manifest renders and you can actually run something. But latest is considered bad. And that's now a lengthy discussion why it's considered bad. But basically, I think it all reduces down to the fact that, Git repository is supposed to describe the state of installed components in a very accurate manner. And if you have latest there, it means anything. What was the moment? When was this pod started? Latest can change meaning throughout the time. So there's a couple ways you can handle this. At work, what we do basically is that we have I think it's something like date, and then build number during that date. So GitHub Actions keeps track of this. These are unique, and whenever you trigger a new build by pushing into the repo, this triggers a new build of the Docker file. And in GitHub Actions pipeline, we have added a script that generates this string, which will be unique for every build, and also at the same time it's readable for a human. Otherwise, you could do also SHA checksums, but then if you look at the SHA checksum, it doesn't help you at all, basically. And in order to inject these values, basically, the last step in the GitHub Actions pipeline is to change the image overrides inside this application of applications repository. So the application of applications repository contains references to all of the components that need to be installed with overrides that specify which tag. And this allows you to roll back nicely. If you do a bad release, then you just roll back to the previous version. And so this is also the other reason why you don't want to use latest, because if you can't really roll back with latest. So you need to have very specifically tagged images so you can do rollbacks nicely. Okay, let me try to show you something which maybe helps understanding. So this harbor operator. So this is a piece that I wrote. This is the thing that actually creates harbor projects for all of you guys, and it also adds access controls to those projects for you, and it also sets up these push and pull credentials into for Canico and Scaffold and all of that stuff. But I think this is maybe the most complex one that I have built, which is publicly available as well. And these are now the values, and the Argo UI nicely shows what are the overrides that are applied for this particular deployment. So let me try to find where is the original. Is it? Yeah. So this is the source, code mover /harbor operator. The other thing is that with Helm, it's very convenient to split up the manifests that you keep one definition per one file if you want to. Obviously here I don't want to. I don't know why. Or have whatever logical separation of components. So in this particular case, Harbor itself consists of multiple pods that are running separately. So I've kept a separate template for every pod and the stuff that it needs to function. So to run Harbor itself, you need Postgres, you need Redis, you need some certificates, you need some passwords that are generated automatically. You need some sort of config maps, whatever the Harbor needs to function, and some stuff which now will differ between different deployments. For example, the host name. Host name is now pulled in from the values, and there's a bunch of default values defined. So I think the defaults were designed for Kspace. So if you're running this stuff on harbor.kspace.de, then you don't need to change anything. But yeah, for the CodeMowers deployment, I have changed the Ingress host, the TLS host, and the traffic target address. That's the CNAME thing that it needs. I think I can actually show how the Kspace's deployment also looks like. There should be no overrides here, or maybe one. Oh yeah, I have actually upgraded the version here, I think. But yeah, the hammer here means that it's overridden the value. So for the CodeMower setup, there's more overrides applied. Any questions so far? It's a spaghetti of different topics, I know. Yeah.
So you were a bit paranoid about typing Helm install. So just as a context, are you also paranoid when you type npm install, or is this somehow specific to Helm?
In npm install, it's pretty much the same story. You will never know what it does, actually.
Yeah, exactly. I see the point.
So basically, the Helm install step is done by Argo in these cases, and what I particularly like is that you can add the application, but it doesn't apply any of the changes immediately. You get to look at app diff. So I have made some ad hoc change here. I'm going to try to explain that in a second. But basically, when you add the application, it would show here in the green that, okay, I would add these definitions when you hit sync, basically. So it gives like a good overview of what is the desired state according to the manifests and everything, and what is the reality in the Kubernetes cluster. And here comes actually now the good part. All of these pesky local changes that we do over SSH, right? Oh, I will go, there's something broken. I will go into this config file. I will change it. It's fixed now, right? And then these minor changes, they accumulate, right, over the years. And then when something very badly breaks, or you need to rebuild the service from zero, who the hell knows what kind of changes were made to actually get it running. So this is what I very much like about Argo, is that if I make a manual change with kubectl, or even if I make manual change in kubelens, let's say I change the replica count, or I change the config map, or whatever, I maybe make a ad hoc quick change to resolve an incident, for example, then Argo will tell you that it's supposed to be 3 according to the Git repo, but in the current cluster it's actually 1. So it does this constant diffing between what is observed by the Kubernetes API and its contents versus what is inside the Git repo. So this is the mechanism that actually will prevent the configuration drift. And configuration drift is actually probably the very first reason why we are doing Kubernetes in the first place. So lots of confused faces. Ask questions.
Looks awesome.
Looks awesome. Let's see, what else?
Alternative, do you know, regards avoiding configuration drift? Is Argo the best way?
You mean in the context of Kubernetes, or? So, okay, if you talk about alternative tooling, there is Flux CD, for example. I tried it once, it didn't work very well. But there is, yeah, I don't know, they're saying that they're graduated. Okay. I tried to use it. I mean, on the paper, it looks better than Argo actually, to some extent. But I couldn't get it working in a satisfactory manner. What other alternatives you have? So, I don't know. You could always do kubectl apply inside your CI/CD pipeline. That's what have been done up to now. But then, what is the problem with that? Okay, let's try to examine what are the problems. If you have these, like for example, if you have like this local change, what happens with that? kubectl apply in the CI/CD pipeline will overwrite it, and probably it will reintroduce the bug that was fixed during an incident. So it will mask these, which I think is a problem. And I still kind of prefer, I mean, depends like on the use case. Let's say if it's like a component of your application that you are shipping, then in Argo you can set it to auto-sync, that the moment you do git commit, it will start immediately kubectl applying the change and updating the, like for example, doing a new release of the component. So, but for infra components, I definitely do not like any kind of automated kubectl apply. If I make some sort of change here, I would first want to examine like what is it going to change in the infra before you actually apply the changes. So that is something that that Argo really helps dealing with. Yeah.
I asked about alternative because it seems like Argo is kind of like a huge product. It allows many things, but if I'm interested only about configuration drift control, and still it makes sense.
Okay, maybe what's worth mentioning, kubectl diff exists.
Yeah, but in some kind of more elegant way.
I don't know. I mean, like I started using Argo. It fixed all of my problems, basically. So maybe one thing that is confusing is that Argo is I don't know what company was it. It's some big company now that's developing this, and under the Argo umbrella, CD is just one of their products. They have, I got into this really silly Slack discussion that I asked about workflows with Argo CD, and then the guy is responding some nonsense. I'm like, what the hell are you talking about? Turns out they have a product called Argo Workflows. So it's just a source of confusion that he was talking about a separate product. I was talking about just, workflows, how do I do stuff with Argo CD? And yeah. But I think for this use case, it's excellent. And it definitely solves lots of issues. And I think maybe like it's because it's like tailored for Kube API that it understands the system that it is used to deploy. It's not like a generic, I will write the bash script that does kubectl apply.
Does it make sense to compare Argo CD and Circle CI as a pipeline to apply changes?
Yeah, I mean that's what I said in the end of the last session that. Like drone, you would use it to, I mean, okay, let's try to put it this way. Drone, I would use to build images only. You can use drone for other things as well, like I showed building router firmware images. I mean, that the only thing that you use there is that the firmware image builder is a Docker image. But Would I do kubectl apply from drone? No, but you can still do it probably. You just have a pipeline element that uses, let's see, Docker Hub, kubectl. I bet this exists. Yes, of course it exists. So there's and it's very frequently maintained. It's used by VMware, must be reputable. I mean, they must know that what they are doing. So I think the use case for this thing is exactly that you could use it in a CI/CD pipeline that is built on top of Docker images, and you could use it to maybe deploy the manifest to the cluster, but it could be something else as well. You could, I don't know, have a pipeline that increases a number in a config map. I don't know, whatever the use case is there. But yeah, I guess like generally speaking, make your life easier by using Docker images for everything, and ship everything as Docker images, and including this CI/CD pipeline elements, make those as well Docker images, because then it will bring some sanity to your world. Otherwise, you're just going to go crazy. And drone is the tool that allows you to do that. I don't know, did I mention last time Woodpecker CI? So the story with the drone is that, let's see, SSPL license was introduced with, I think it was Elasticsearch, right? I think Elasticsearch was the root cause for SSPL. SSPL is server-side public license. It's very similar to this GNU AGPL license, but it's not approved by open source initiative. Open source, which one is it? OSI initiative or institute?
By nobody.
Huh?
It's not approved by nobody.
Yeah.
You cannot offer it as a service.
Yeah. I mean, that's a whole other discussion that, you know, license text is supposed to have, I mean, should have at some point some sort of test in a court to check how valid it is, how far can you actually enforce it. We've had examples with GPL license. So most notably, maybe Cisco was sued for infringing GPL license, and they had to comply by releasing the source code for these, you know, these blue routers, WRT54G. So that was a court precedent for enforcing GPL, that this text is valid and you know, enforceable. And after that, companies started got really scared about GPL, and then, you know, many companies started avoiding GPL. And but the thing is that GPL license doesn't cover software that is running on a server. As a service user, you are not entitled to the source code of that software that is running on the server. And this GNU AGPL license tried to cover that scenario. And SSPL does the same thing, basically. It basically says that if you're a service provider and if you're deriving from Elasticsearch, you're supposed to release the changes for sure, but the ambiguity with the SSPL license is that it might also cover your infrastructure tooling, which is specifically targeted attack towards AWS. So basically, why Elasticsearch went with SSPL was that AWS started adopting Elasticsearch for AWS, and they just basically took the code, make it a enterprise offering based on that, and they didn't give anything back to the Elasticsearch authors. And Elasticsearch switched to SSPL. And basically, the SSPL text is so scary that nobody touches it, because they are afraid that even if they use it without any changes, the infrastructure plumbing might be affected by this license, that you need to release. Like basically, AWS would have to release their whole infrastructure code base, which, I don't know, I guess we'll see and wait what actually happens. Sooner or later, there will probably be a court precedent which nails down like what is the scope of this license. So that's the background story. Same thing happened with drone. And Woodpecker CI is the last, Drone now uses also SSPL license, but previously they didn't. And Woodpecker CI is a fork of that code base that doesn't use SSPL license. It's being separately developed now. So I guess one day I would probably explore switching from drone to Woodpecker CI, but I learned about this just like a couple months ago that it exists. I never really dug into that because drone was pretty well documented and I got everything working that I needed. And but yeah, like if I would find SSPL bothering, then maybe I would switch to Woodpecker CI. But what was the original question?
Circle CI versus
Yes, okay. So yes, Woodpecker drone, Circle CI for building images. But let's say if you trust your drone installation that you give it like essentially root access to your Kubernetes cluster, why would you trust Circle CI with your Kubernetes root credentials, basically? And that's why I would draw a line there, that I don't want the CI system to be able to actually modify anything in my Kubernetes cluster. Because essentially this would allow them to, let's say if the Circle CI service gets compromised. And we've seen now recently lots of cases where these, I think one of the CI systems got compromised a couple months ago.
They get compromised all the time.
They get compromised. So is that the place where would you want to keep your kubectl apply read-write permissions, basically? Probably not.
So what is the alternative to keep those credentials or do it manually?
Yeah, I mean, if you don't want to use Argo, then yes, you can do kubectl apply manually. But if you want to do it in automated fashion, that's where you split the concerns that Argo is now inside the cluster. That's your trusted place anyway. Okay. You give Argo the permission to make changes to the cluster, and Argo will pull the changes from GitHub. I mean, if you can't trust your Git source, then you're kind of screwed anyway, I guess. Did anyone order pizza? Can anyone order pizza? Okay.
YouTube has questions.
Yeah, what questions?
You probably answered how drone fits into the Helm and Argo ecosystem. That was answered, I think.
You can ask more like.
But the next one is have you defined Kaniko? Like what that is?
What is Kaniko? Yes, let's go again over Kaniko. So basically, inside Woodpecker and drone and Circle CI, you can do Docker build. I think that's pretty much universally supported everywhere, right? I mean, that's the basic assumption there. But the problem with the Docker build is that it needs the Docker daemon to be running somewhere. And if you have Docker daemon running somewhere, it means that you have very highly exploitable var lib docker blah 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 socket, where you can connect to and tell, please start as root, whatever, basically. And Kaniko, in that sense, helps to, let's see where I have the, where do I have the repo? So this is the repo. This is essentially the thing that wraps Kaniko for drone. And Kaniko itself is a Google, it's not official actually. Let's see, Kaniko. Google Container Tools is the repository. Build container images in Kubernetes. I think you can actually run it locally as well. And basically the point is that it's a tool that allows you to use Docker files without any changes, but without the actual Docker runtime. So basically Kaniko reads the Docker file. You know, if you have an add instruction, it will copy the file to the right place. If you have a run instruction, it will probably do something like chroot into the folder and run the command there. But it allows to do the Docker build step without the actual Docker. And this is exactly what you want to have in a Kubernetes cluster, because at the moment, none of the infra that we use here, I don't have any more Docker anywhere. There is no Docker runtime. There is no Docker build. Even if I had in the slides Docker build, that was just illustrated. It was something that is being built with Canico. And yeah, this was built by Google. And if you would want to use maybe lame term, let's call it a Docker file parser or Docker file interpreter, or I don't know, however you want to call it. Because what the traditional Docker does, it takes the Docker file contents and it sends it over the Docker socket to Docker, deal with this. And then the actual Docker daemon reads the file and then does something like in parallel or something like, But it does the same thing without all of that actual Docker complexity.
So it doesn't need root access?
Yes, it doesn't need root access, actually. That's what I wanted to mention as well. And you can, like if you run it with the drone, then you can achieve the situation that in order to build an image, you have a pod started with Canico inside with no elevated permissions. It manages to build the image and then it pushes it to the harbor without needing root credentials anywhere. But yeah, this particular repo is the thing that wraps Canico for drone, because drone has predetermined environment variables that it feeds into the into this plugin.script or shell script. And the plugin shell script, this was from somewhere on the internet, it just wraps a bunch of these, passes the variables into the right place. Overall, it makes everything faster. That's another thing, because when you build stuff with Docker build, it's mega slow. Everything is mega slow. Like if you compare Canico to drone, the speed difference is quite drastic, I would say. Because one thing is that Docker snapshots every layer, but Canico doesn't do any snapshotting either. It just executes all of the things and then packs it as a Docker Docker image.
Do you use it in production, Canico? Do you adapt?
At work?
Yeah.
No, because we use GitHub Actions at work, and we use whatever was I mean, I didn't set it up, so. But for the case-based repo and for the code mowers, both cases, drone runs on our own hardware inside the same Kubernetes cluster. Canico is invoked in the same cluster. All of the images get built on the same cluster, get pushed into the Harbor registry that is in the same cluster, and then the cluster itself pulls the images from the Harbor that is inside the same cluster. So, any more questions?
Slightly different question.
Yeah.
About Helm.
Helm, yes.
You said that it helps to describe architecture or scheme of your cluster or whatever. Maybe it's too complicated question, but it would be nice to see some examples. Why? Because I recently started to use Helm, and it would be good to know for me how to represent how Helm can help to represent complexity.
Okay, so like for example here in the Harbor operator that I wrote, templates. So it nicely allows you to split up the manifests, that you don't have one big manifest file or something like that. And
There should be these templates, value, chart files, but here only YAML.
no,
Template. Okay.
yeah, that is inside the templates.
Okay.
So you have the chart YAML, values YAML, and templates. Default ones are just for K-space, and templates are, you know. And there's maybe one thing that is worth mentioning. Like if you're using, if you're deploying some, external projects, like I think nearly everything has their Helm charts. Like, you want to install Harbor, or if you want to install Argo, they will have their Helm templates. But the problem is that many of them, they make a bunch of assumptions about your infra. Like, for example, the original Harbor Helm chart assumed that the persistent volumes can be mounted into multiple pods, because they assumed that you are running such persistent volume provider that allows that, like NFS. With NFS, you can actually do that. In AWS, they have what is the equivalent, EFS, I think, CEFS. And with EFS, you can actually mount the directories into multiple EC2 instances, and the Helm chart works there nicely. And then you can have you can run multiple instances of Docker registry because they're accessing the same file system. So, but that doesn't work if your storage provider doesn't allow that. So, in particular, if you're using like a classical block storage like Longhorn, or even if you use these EBS volumes from AWS, then these volumes do not support mounting into multiple pods or multiple hosts. So that's like one example where a Helm chart author makes a bunch of assumptions about your infrastructure, and then you end up basically throwing away the whole thing and writing it from scratch. So this persistent volumes is one example, but there's more. Like I think the even more frequent problem is what the hell do you do with Redis? So every goddamn Helm chart has needs. I mean, the application needs Redis. That is the starting point. So the Helm chart authors, they do their minimal viable product. Okay, we will give you a stateful set for Redis, so the Redis will work and your application will work. And then, if you want to have high availability, then screw you, basically. And that is basically said in many projects that, oh, by the way, this Helm chart doesn't support high availability, so you have to rewrite it yourself in order to actually have high availability. And this actually, for some of the projects, then what they do in the Helm chart is that they have some sort of configuration flag that I want to use external Redis, like from AWS, Elastic Cache, or whatever SaaS, whatever offering. So that is like slightly better situation. But then my still utopic future is exactly what I have here, which now hooks back to the operator pattern and all of the stuff that I've been blabbering about for the past months. How about standardizing a resource definition for Postgres? This application needs Postgres. Is it highly available? We don't care. I mean, the application shouldn't care. It's an implementation detail. Same goes for Redis. Like, this application needs Redis, but where it's hosted, is it on RDS, or do we run a cluster locally? That should be hidden. So I am anticipating that something like this will become normal within next, okay, let's be optimistic, 5 years. So it will likely take years to get formalized, because I would say this needs to be a standard, that you have a definition to request these external resources. And then that should cover also, all sorts of services like Kafka or RabbitMQ or MQTT or whatever it is, that you can order these resources from the Kubernetes cluster. But yeah, the current status still is that if you install applications with Helm, then of course the application developer, they want to give you like a working example, like a complete example. And if the application depends on Redis, well, they will figure out some sort of half-assed way to put the Redis inside the Helm chart, so at least your application works. But the main issue still is that it makes a bunch of assumptions about the environment where the application will be running, and you will spend time trying to understand actually for what kind of environment was it built, because Harbor is developed by VMware. So I suppose the way VMware does this Tantsu Kubernetes cluster is by having these probably NFS shares mounted to the pods. I don't know exactly how it's implemented. And in that environment, mounting the same folder to multiple pods works. And they say that everything works. So for that particular setup. But the moment you need to use EBS volumes, then screw you. Okay, any more questions?
What about Podman versus Kaniko?
Podman versus Kaniko. These are like it's like apples and oranges.
Okay.
But Podman is more closer to wait, what was that? That was like more like Docker kind of a thing. Yes. So okay, let me try to. That's very opinionated sentence now, but. OpenShift is the Red Hat abomination of Kubernetes, and Podman is Red Hat abomination of Docker. It's just trying to be special. That the only selling point is like that stuff doesn't run as root, and then it messes up everything else. And you see even in the Helm charts, like if it's OpenShift, do something differently. Like what the hell? So I think it's the same, it's the same not invented here culture and syndrome or whatever you want to call this. It's just Red Hat trying to have some sort of, I don't know, vendor lock-in or whatever you want to call it.
So basically ignore Podman, Kaniko.
I don't see how Podman, I think Podman still uses the Docker socket.
No, it doesn't.
No, it doesn't? Okay, so, okay.
It's standalone.
Standalone.
Yeah.
I don't know enough, I would say, at this point. But I guess like the general answer is try to strive for something that doesn't use the Docker socket, because like architecturally it's cumbersome, and to build an image you don't need that. And even just to maybe think outside the box, you could write your own language to build a Docker image. Docker file is just like.
It's actually, I have written Docker file parser under 500 lines of Python that builds the images.
But it probably doesn't support some sort of corner cases, right?
It doesn't support downloading files from the internet.
Okay.
So.
This reminds me, like the last time, we very quickly went through the stuff in 2 hours. I wanted to mention actually more things about Docker files. What would be a good example? I don't know. Let's look for whatever, not Nginx, but where can I find just a random Docker file? Something smells really good. Is popcorn? Because I don't have any of them here, but when you need an example, there's no example. No, I actually wanted Docker file UID something something. So there's so many threads on this, and there is so much noise about this. But generally speaking, okay, let's just open up this one. So if you use like vanilla Docker, then yes, these steps, I think they run as root. They are confined to the container in the build stage, so they cannot access your desktop files, I suppose. But these steps are still running as root. in my opinion, that is fine. It's just the problem of the Docker itself, that it runs them as root. And that's where the Kaniko comes into the picture. If you build it with Kaniko inside Kubernetes cluster, you can actually set the security context for all of these. Let's see, where do I have security context? Yeah, this is the security context. So this is something that you can set for every pod. And it basically says that the UID of the process should be 1,000, the GID should be 2,000, and this actually sets the ownership of the directory that is inside the persistent volume. And all of this should allow us to forget about doing these stupid steps inside the Docker file. So what I see everywhere is that they have run add user blah 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 with the UID 1,000, and then they do something user 1,000 to demote the privileges, and then inside the goddamn init script, what they do to overcome these security issues, they will have an init container that runs chmod over the persistent volume folder. This is insane. And one of the problems is that setting this file system group UID was added rather recently into Kubernetes. So it's like a twofold problem. One thing is that Kubernetes didn't support some of these things up to somewhat recently. But at least from now on, do not add this into the Docker file. If you're concerned about the build step security, then build the images with Kaniko. And if it's in a circle CI, you don't give a crap anyway, right? It's their problem. But if you build it on your own infra and you're worried about security, then figure out how to get Kaniko running without root privileges. That's the logical way to do this. And then you remove this complexity from here. And when you actually run the application, then specifying the security context for the pod should be sufficient to drop root privileges. And then you don't, when you use this FS group to specify the persistent volume permissions, then you don't need these stupid init containers that basically do chmod and chown on the data folders. And I've seen it so many times. It's done everywhere. Is there anything else?
No.
Any more?
I guess we can wrap it up.
So far.
There's probably more to discuss, but I'm kind of tired. Yeah.
Hour and 30 minutes.
So yes, this one was very spaghetti talk. I hope this sort of tied the loose ends together somehow. I think for the next week we have hopefully Renno coming from Pipedrive to talk about security, and I requested all of the security features that he would, if he didn't know, at least he would figure out what they do and how they do. And I hope he'll be here next week Thursday talking about that. And after that, we have Sander coming from Tartu University to talk about, they run a high-performance computing cluster there with on-prem Kubernetes. And he's going to come and talk about that. And I guess the very, very last session on, 30th of March, I think, let's talk a little bit about Prometheus then, maybe. There's maybe some thoughts about how to name the metrics. Naming metrics is you have to tell people at least, 3 times and show them why what they did doesn't make any sense. And then eventually they start understanding, and then it's wow, that you could write a generic alerting rules Maybe like some of the alerting rules you could actually bring back into the central repo because they are so generic, they work for every microservice. Okay, I think that's it for today. And